Hello, and welcome back to another tutorial in the Rollerball series. In the previous episode, we enhanced our game's visuals by adding world shaders, in-game UI, and more. However, the game still feels a bit lifeless. There's no audio to accompany the actions we perform. In this video, we'll learn how to bring our game to life by adding sound effects when picking up coins and background music to play while the game is running. Let's get started. First, let's add the audio files to our project. Start by creating a folder named Audio in the Assets directory. Then, import your audio files into this folder. If you'd like to use the same audio files as mine, the download link is provided in the description below. With your audio files ready, it's time to manage them. We'll do this by creating a script. Let's create a new script and name it AudioManager. We'll start by creating variables to manage our audio sources and audio clips. First, define two audio source variables, music source, which will handle background music, and SFX source for playing sound effects. Next, we need four variables to store the audio clips, which are the audio files used in the game. These include coin clip for the sound when collecting a coin, destroy clip for the sound of object destruction, menu music for the background music in the menu, and in-game music for the background music during gameplay. You can also use the header attribute above your variables to group them into sections in the Unity inspector. This is purely for organization and doesn't affect the functionality of your script. It's especially helpful when working on larger scripts, as it makes it easier to locate and assign specific variables, such as audio sources and clips. Adding headers improves readability and streamlines the workflow without impacting performance or functionality. Now let's quickly switch over to Unity. You'll notice the variables we created in our script are visible in the inspector. To assign them, we'll start by creating an empty game object and renaming it to AudioManager. Next, attach the script to the game object. You'll see how the header attribute is working. It neatly groups the variables by adding space between them, making them easier to identify. Now let's assign the audio clips. Since we've already imported them into our audio folder, we can simply drag and drop them into the corresponding fields in the inspector. For our audio sources, we'll create two empty game objects, one for music and another for sound effects. Select each game object and add an audio source component to them via the inspector. In Unity, an audio source is a component that plays audio in the scene. It acts as the player for audio clips, allowing you to control properties like volume, pitch, and whether the audio should loop or play just once. Once the audio sources are added, we can assign them to their respective variables in the AudioManager script. This setup ensures that music and sound effects are managed efficiently and don't interfere with each other during gameplay. Let's return to our code. To make the AudioManager accessible to other scripts, we'll use the singleton pattern. This ensures that there is only one instance of the AudioManager throughout the game. Here's how it works. First, we define a static variable to hold the AudioManager instance. Then, in the awake method, we check if an instance already exists. If it does, we destroy any duplicate objects to maintain a single instance. If no instance exists, we assign the current instance and mark it as persistent across scenes using Don't Destroy on Load. By doing this, we ensure our audio system stays consistent and functional, regardless of how many scenes our game contains. It's a simple yet powerful way to manage global systems like audio. To play music, we'll define a method called playMusic. This method takes an audio clip as a parameter and uses the music source to play it. First, we check if both the music source and the music clip are not null. This ensures we don't run into errors when trying to play music. Next, we assign the provided audio clip to the music source. We then enable looping on the music source, so the music automatically restarts when it ends. This is essential for background music to create a seamless and uninterrupted experience. Finally, we call the play method on the music source to start the music. This approach ensures that background music plays smoothly, enhancing the overall feel of the game. Similarly, we'll create another method called play SFX to handle sound effects. This method will also take an audio clip as a parameter. Check if both the SFX source and the provided audio clip are not null. Then, use the play one-shot method to play the audio clip. The play one-shot method is ideal for sound effects because it plays the clip immediately without interrupting any audio already being played by the source. This ensures that multiple sound effects can overlap smoothly, creating a more dynamic audio experience in the game. If, in some cases, we want to stop the music from our music source, we should create a method called stop music. Inside the method, we simply call the stop function on the music source, halting any music that's currently playing. We don't stop the SFX source, as sound effects are short, non-looping clips, such as the sound of picking up a coin, and they typically finish playing on their own. Finally, let's start our in-game music in the start method. We'll do this by calling the playMusic function and providing the in-game music clip as the parameter. Save your script and hit play. As the game runs, you'll hear the beautiful background music seamlessly playing in the game, adding a polished touch to your experience. But we're not done with the coin yet. The pickup audio should play every time our player collects a coin. To achieve this, open the coin script. Inside the onTriggerEnter method, when the player collides with the coin, we'll play the sound effect. We can do this by using the AudioManager instance we created earlier. Simply call the play SFX method and pass in the coin audio clip as the parameter. This way, the sound effect is triggered perfectly each time a coin is collected, enhancing the player's experience with satisfying audio feedback. Now, when we run the game, you can experience the coin sound effect each time a coin is collected, and the background music playing seamlessly adds a polished touch to your game. It's a simple enhancement, but it makes the gameplay much more engaging and enjoyable. Feel proud of what you've accomplished so far. Adding audio is a big step in creating a professional and immersive game. If you encounter any difficulties or have questions, feel free to drop a comment below. Don't forget to like, share, and subscribe for more tutorials. Your support means a lot, and I'll see you in the next video. Happy coding!